Hi and welcome back. In this video, let's talk about testing, specifically testing Python apps with Pytest. Testing tends to elicit different emotional responses on different people. For some, it's tediousness. They find testing boring. For some, it's fear, because testing tends to be something you don't really learn about, so a lot of people are scared about it. But many people know that testing is a hallmark of quality software. So Pytest is a very straightforward and powerful testing framework for Python. Let me show you how it works. Whenever we write code, let's say one function, it's easy to focus on the one scenario that we've got in our heads for where we're going to use that function. And it's easy to forget that we may then want to use that function someplace else in our code. That's why it's quite easy to write a function that works now, but not so much that works later. Here's a simple example. If you want to call this function in your code and you already have values for x and y, then dandy. But it's easy to forget that in other places in the code, y may be 0 and that would raise an error. Writing tests while you write your code helps put you in this state of mind of analytical thinking, of thinking what inputs is this function going to take and what outputs is it going to produce. Plus, tests act as documentation. Once you've written all your tests, you can look back on them to see exactly what you thought at the time regarding how the code should work.
I've created a file called requirements.txt and I've put Pytest in it. Now I'm going to use pyenv to select 3.11 as my Python version. Pyenv exec python-mvm.vm will create my virtual environment, and then I will make sure to select it and activate it, and then do pip install-r requirements.txt. If you're not familiar with using pyenv, I've got a blog post on that I'm going to leave linked down in the description below this video. And if you're not familiar with virtual environments, we've got a big tutorial covering them as well as a blog post, and I'll leave both linked below. Okay, so we've installed Pytest, now we're ready to run it. Let's create a file called testsimple.py and I'll show you how Pytest works. I'll create a function called testSimpleAdd, and in here we're going to assert that 1 plus 1 is equal to 2. So obviously a very simple function, but you've already seen a couple of things that we need in order to make Pytest work. The file has to be called test underscore and then whatever name you want to give it. And each function is a test, and they also have to be called test underscore and then a descriptive name telling you what this is testing. Each test function should only test one thing, and each test file should cover probably one file of your program, or at least one concept. Now to run this, we just run Pytest in the console, making sure to have our virtual environment active, and it runs a test. Pytest is going to discover tests by that naming convention, test underscore and the name, or the name and then underscore test, but I like putting a test in front. If you wanted to make a tests folder, which is a pretty common thing to do, you'll need to also create a dunder init.py file in there so that Pytest can go inside tests and discover the tests there. For this tutorial, we're not going to be creating a folder. We can also create another test that is going to fail. We're going to say that assert A is equal to B. And now I'll show you what happens when a test fails. You can see we get an assertion error, and it says that A equal B failed. And you've got a bit of a diff there that tells you what was the thing that failed. Basically, we expected B, but we got A. I'll use this opportunity to show you how to run only specific tests in Pytest. You can do Pytest-K and then a string that will match the test names. For example, if we just put add in here, you can see that only one test runs. That's denoted by the dot that is green. And that's because only this test ran, since this test doesn't have the word add in its name. I should also tell you about test outcomes. You can see so far we've got passed tests, failed tests, and also deselected tests. There's more you can do with tests. You can skip certain tests, for example. To skip a test, we go to the top of the file and we import Pytest, and then we're going to skip this failing test. We'll do @pytest.mark.skip. Now when we run our tests without the K flag to run everything, you can see we get a dot, which tells us the test passed, and an S, which tells us the test was skipped. You should seldom skip tests. That's because a skipped test just pollutes your code but doesn't tell you anything. Sometimes we have to skip a test when we depend on a third party and that third party is failing for some reason, and we're going to remove the skip very shortly. But most of the time, if you are consistently skipping tests, it's best to either rework the tests or delete them. You can also mark a test as expected to fail. So this test will fail, and if that's what you want, then you can mark it as xfail. Now running the test tells you that one test passed and one X failed. And that means that it was expected to fail, and it did. So technically it passed. Now if you say A equal A, now this is true, so the assertion is true, this test would pass, but you've said it should fail. So when you run the test, you get a capital X instead of a lowercase x, and it says 1x passed, and you can see it's bold there. That's the failing test. Circling back to skipping tests, sometimes you have to skip a test if that test doesn't work for some specific reason. And usually what will happen is you'll have a test that is skipped conditionally and then another test that is skipped in the opposite condition. For example, let's turn this back to failing and say we're going to skip this test on Mac because it doesn't work on Mac. We'll say skip if OS name equal POSIX. We also need to import OS. Running this test shows us that we need to provide a reason for skipping this test. So we'll say reason equal does not run on Mac. And there you have it. Now we get one passed and one skipped test, but on Windows this test would run. Obviously with A equal B, this is not a very good example, but let's say you are making a graphical application and you want to skip a test that would display a button that doesn't render on Mac, but it does on Windows. You could have that test in there. And then you would probably have an opposite test that is skipped on Windows, but not on Mac, that tests what the expected behavior should be on Mac. This also brings us to the last test outcome in Pytest, other than passed, failed, skipped, X failed, and X passed, which is error. And so obviously if there's an error in your test, you get that, and that means the test failed as well. And you can see the E in the console, which tells you that that's what happened. All right, let's delete test simple.py, and I'm going to show you the example that we're going to be working with for some more advanced tests.
Before we continue, please let me tell you about our latest course. It's called FastAPI 101, and it's a comprehensive course teaching you how to write back-end applications with Python using FastAPI. The course is not out yet, but if you want to get notified when it does, then please sign up using the link below, and you'll get notified, and also you get a nice discount on launch. All right, let's continue with our more advanced example.
We've got reply.py, and you can think of this as a representation of a reply in a forum thread. We're going to look at thread.py later on. The reply class has an init method with a body, user, and the created time, and that just assigns the properties. Then you've got a repr method that displays what this is going to look like when converted to a string. And finally, you've got the dundereq method that compares two replies to see if they are the same or not. If you're not familiar with dundereq, well, you will be by the time we're done with these tests. So let's write some tests. We're going to write a test that verifies that the init method works, i.e. when we create a reply, do the properties get created and are the properties the ones that we expect? We are going to have a test that calls repr and checks that the response is correct. And then we're going to test the eq method with two reply objects with the same data, and that it should return true, with two reply objects with different data, and then it should return false. And we're also going to test it with a reply object and something that isn't a reply object, and then it should return false. Determining what tests to write is a big part of testing, and oftentimes you have to do a bit of analysis as to what are the different types of value that your functions and your methods may take, and then you want to test something within that type of value. If you're dealing with number ranges, then you often have to find the boundaries of those values. For example, if you were testing how many of something has, you would test 0 and 1, but you probably wouldn't have to test 2, 3, 4, 5, etc., because they all should behave in the same way. Let's create test reply.py, and in here we're going to import datetime, and we're going to say from reply import reply. Then we're going to write our test init. Here we're going to use a very frequent formula for writing tests, which is the given, when, and then structure. Given tells us what is the data that our test requires or depends on. So we'll say body is hello world. This is the body of the reply that we're going to create. The user is user1, and created is datetime.datetime.now. Now, what is the test actually going to use? Well, we'll say when equal reply of body, user, and created. Finally, what is the thing that we're actually testing, or what happens then? Well, we assert that the reply body is equal to body, we assert the reply user is equal to user, and the reply created is equal to created. Let's run these tests, and you can see that that passes. In the repr method of our reply objects, these have access to the self.created attribute and self.user, but self.created is particularly interesting because we're actually calling strftime in it. And that means that self.created must be a datetime.datetime object. Now, the type hinting is already helpful because a user of your reply class should pass a created value, which is a datetime object, but they may not, or maybe you don't in your code for some reason, or maybe you made a mistake. So the test is going to make sure that created is indeed a datetime object and it is used properly. So let's go over to test reply, and we're going to write test repr. Here, just as before, we're going to have our data. Then we're going to create our reply. And now we're also going to create the expected repr. And now you may be tempted to do this. Put an F string in there and say reply from user on, and then put created.strftime. And this is getting pretty confusing, but this is essentially the sort of thing that you may think of doing. And then the closing crocodile clip. And this will probably give you the right thing. Repr reply equal expected repr. We forgot a quotation mark there. And now it does. Which, by the way, actually, let me take that away again and run this. And you can see that we've got a small mistake here. You can do Pytest-V for a more verbose differential, and you can see that this is where the problem lies. So let's add that back in. And now this should pass. If you use Pytest-V, but all your tests pass, you see this. Without -V, then you just see the two dots there. So anyway, why is this a mistake? Well, because the test and the code do the same thing. They both call strftime. So if you make a mistake in here, and then you basically do the same thing here, which you might be tempted to copy-paste, which would be an even greater mistake, then you're not going to figure out what the problem is. So the better thing is to not use strftime in here, and instead do 2023-01-01-0000. Of course, now this fails because the current time is not 2023-01-01, so this is another mistake. Just create a datetime object and actually give it a specific date and time, and that way the test will not have to change every day when the day passes. So let's run this again, and you can see it passes. Because we're not doing any processing on the user, I think this is fine, but you could just put user1 in there, although that kind of defeats the point of having a separate variable. So what happens when somebody passes something to the reply init method that isn't a datetime object? Well, the repr will fail because it will try to strftime the datetime object, but it won't be able to. So let's try that out. We create a function test repr without date, and then we're going to define our body and our user, but now created is going to be a string. For example, this may happen if you're getting your data from an API and it gives you a string and you forget to turn it into a datetime object. You may be tempted to just pass it the string, but this is not going to work. So we'll say reply body user created, and this will be fine. So we can say assert reply dot created equal created, and this will actually pass. Even though the data type is incorrect, it's fine because Python doesn't enforce data types with their type hinting. So instead what we'll do is we'll say with pytest.raises, and it's going to raise an attribute error, and we'll then assert that the wrapper of the reply should be equal to the thing that we had here. But we can change this to 2021-02-07 at 12. Remember, if we don't have Pytest imported, we'll have to import Pytest at the top. Now, running this test, you can see it passes. As well as pytest.raises, there are other Pytest helpers that are super handy. I'd recommend you read the official documentation, which I'm going to leave linked down below, but I'll show you one and that is test almost equal, and this one's super handy. Let me bring up a Python console in here and I'll show you an example of where almost equal can be handy. Let's say we've got a number and then we say B is A divided by 77, C is B times 77. And so C and A should have the same value, but actually C has the value of 9.9999998. That's because there are inaccuracies in the calculation of floating point numbers in any programming language. It's just a limitation of computers rather than of Python. And so almost equal can be handy because you can check that these numbers are so close that they might as well be considered equal. So in order to do that, we are going to say something like x is 5, y is 5.01, and now we can do assert x equal pytest approx y and give it 0.1. Oh, 2 equal signs in there. Now you can see this passes. If we change the 0.1 to 0.01, then this still passes. If we change it to 0.001, now this fails because this is the allowed difference in y that would be considered equal to x. Now let's move on to testing the equality. So we'll say test eq, and now we're going to copy this one here, for example. Paste it in there, making sure that created is a datetime object. I'm going to delete the expected wrapper. I'm going to rename these replies reply1 and reply2. And now we'll say reply1 equal reply2. Let's run the tests and you can see it passes. Now we can copy this, but make it different data. Test EQ different data. Now instead of creating a reply with body, user, and created, we're gonna do user2 in there, for example. And now this one fails. So we change this to not equal, and now it should pass. Finally, let's copy this one and make it so that reply2 isn't a reply object at all. This is a string. And now we'll say not reply, for example. And now that passes as well. So now we've tested our reply pretty thoroughly. We are ready to move on to the thread class. So our thread class has an init method with a title, user, and a list of replies. And then it's got a wrapper method, which just displays it as a string. And finally, there's a reply method, which appends something to self.replies, a reply object, as long as that reply was created more recently than the last reply in the thread. It wouldn't make sense to be able to add a reply to a thread that was created before the latest reply. That would be nonsensical, so that's what that does. Although there is a small bug in there. The first tests for init and wrapper are fairly straightforward. Let's create a file called testthread.py, and I'm going to bring in some code that I've got in my notes. So here we import thread and reply as well as datetime, and then we've got test init. Here we just create a title, user, and the replies, which is a list of reply objects. And here I'm using datetime.datetime.now because it doesn't really matter. We're not comparing the replies themselves. We don't care what's in them. And then we create the thread and we assert that the properties are set. Then for wrapper, it's basically the same thing as we've done before. We just create the thread and then assert that it is correct. Now let's write our test reply. So we'll do test reply. And again, we have our title, user, and replies. And I know there's a bit of duplication going on. We're going to fix that later. And then we'll create our thread. And now we'll create a new reply. So we'll say reply hello world from user1 datetime.datetime.2023-13000, and I'm going to change these to be a specific day and time, 1 and 2. So that's the 1st of January, 2nd of January, 3rd of January. Now we'll say thread.reply new reply. and assert new reply is in thread.replies. And you can do this, oh, sorry, that should be in. You can do this in here because new reply can be compared to every other value inside thread.replies because it has a dunder EQ method. All right, let's run this. But you can see we get a value error. The new reply is older than the last reply. How can that be? Well, clearly this is 1, 2, and 3, so this should all be fine. And this is why writing tests is pretty helpful, because in the thread we have obviously made a mistake. This should be less than, particularly when dealing with dates and, greater than, which date is younger or older or earlier or later. It's pretty confusing. I tend to make mistakes with that. And so writing tests really helps you define what should pass and verify that that's correct. So there you have it. Now we can have another test for replying where the reply is indeed older than the latest reply in the thread. So we can create our title, user, and replies. This one is on the 1st of January and the 2nd of January, and then we'll add another one that was back to the 1st of January. So this shouldn't be possible. Let's import Pytest at the top, and now we can run these tests, and you can see that that passes. By the way, if you want to only run the test thread, then you can do that just by saying Pytest test_thread.py, and it will just discover the tests within that file. Now you may have noticed all of these tests here are pretty similar in that they all start the same way. They define the title, user, replies, and thread, and then they check something. So we can use a fixture to simplify and reduce the duplication. But before I tell you about fixtures, here's something that you could try. You could try taking this out and putting it in here, just as variables. But instead of datetime.datetime you probably should use a specific date and time. So let's do this and that. Okay, so now you can get rid of everything there and just check thread title is equal to title. In here, you can check that the wrapper of thread is correct. Then you can get rid of all of this and just create a new reply. Here you can do this, and that's it. And this actually works. All the tests pass, so it's probably fine. But there is a problem with this, which is why I don't recommend you do this. And that is because you're using the same thread variable for every test. So when your tests start modifying the variable and adding things to it, etc., you could run into problems. So it's better to use a Pytest fixture, which allows you to do exactly this, but make sure that each variable is created for each test function and it isn't shared between different tests. So let's create our fixture, and we say at pytest.fixture. We're going to say here scope equal function, although this is optional because function is the default value, and we're going to call it thread. And then in here we're going to move this stuff and make sure the indentation is correct. And now we're, instead of thread equal that, we're going to return thread. Now each test can gain access to this value and run this function using dependency injection. So just put the word thread in here, which matches the name of this fixture. And when Pytest runs this test, it will see that there is a fixture called thread, and it will run it and give you the value. Pytest will discover fixtures in the current file first. If there are no fixtures named thread in the current file, then it moves to another file called conftest.py. And so this is the name of the file where Pytest would look for fixtures if it couldn't find one in here. And if that fixture is not defined in conftest.py, then it would go to the parents folder conftest.py if it can, and so on until it reaches the root of your project. So obviously we don't have a parent folder here, it couldn't do that. And finally, if the thread fixture is not defined in any of the parent folders conftest.py's, then you would get an error. So that's how the discovery of fixtures goes. So yeah, now you could just put thread in here into every test and you'd be good to go. But now you have another problem, which is that title, user, and replies are no longer defined. So how are you going to check that the thread's title matches something when that's defined within this function? And this actually brings me to something else, which is that the fixture is going to create a thread for you. So this fixture is actually a thread that has already been created. I don't like using a fixture that tells me a thread has already been created when I'm testing that I can create a thread. So I would actually not use the fixture in this test. I would copy this and have that in here just for this test. Just like that. And now down here, I would hard code the value. So the value is hello world and the user is user1. And of course, remove the f string from the front. Now all your tests pass. So this helps us answer the question, what are fixtures? Fixtures are functions that return a value that can get dependency injected into any test, thus allowing us to reuse variables and basically reuse any data. Scope equal function means that this will get executed for each test that uses it. So that can be handy, but in some cases you may want to only run this function once for the entire file, and then you actually want to reuse the value across the entire file, and then you can give it scope equal module. If you do scope equal session, then this only runs once for the entire test suite, which includes all your test files. That can be handy, for example, for connecting to a database or things like that. And there's also scope equal class, and this allows you to define a fixture that was only ran once for the test class that you've defined. Using classes with Pytest allows you to group tests together inside a class, but I almost never do it. I almost always use modules. Also, scope equal function is the default, so if you are using scope equal function, you can just not put it in there, and then that's the same thing. If you have multiple fixtures, you can just comma separate them, thread and then something, and this would give you the values of your two fixtures, thread being one of them, something being something else. So if you wanted to use a database, for example, you could do thread comma db, and this would try to get your db fixture if it exists. If you want to see what fixtures each test is using, you can do pytest -- fixtures per test, and then it's going to tell you the fixtures that each of your tests used. If you do pytest -- fixtures, then you'll be able to see all of the fixtures that are available. And you can see there's quite a lot of them. All right, so that was a lot of information. We've written a lot of tests. All the code and more explanations are available in the blog post, which I'm going to leave linked in the description below. So please consider checking that out if you want. And yeah, we've covered the basics of using Pytest. So I hope that you've learned something and you've enjoyed it. And remember to write tests. It's pretty important. It documents how your code works. You can just read the text and say, okay, the reply object has a reply method and this is how it's meant to work. So this acts as documentation and also it keeps you right so you don't add any errors to your code. As long as you write good tests, that is.
All right, this has been a long one. I hope you've learned a lot about testing and Pytest, although we've only just scratched the surface. Testing doesn't have to be a very complex activity, although it does take a little bit of time to come up with all the test cases and scenarios and to actually write your tests. Although AI tools such as Copilot are really good at helping you write tests, let me know down below in the comments if you'd like me to make a video on writing code using AI tools. For further reading, I strongly recommend checking out the official Pytest documentation. Also, there's an excellent book on Pytest called Python Testing with Pytest, and I'm going to leave both of these linked below. Thank you for joining me. Remember to like and subscribe, and I'll see you in the next video. Happy coding!